Oh my god.
So terminal velocity is the fastest something travels when falling towards it. So like every planet has its own terminal velocity. Mm-hmm. So when you jump from a plane, you keep accelerating, but then you accelerate to a point where you can't accelerate anymore.
Oh, is that why they literally did look like they were falling in more slow motion when it was just beginning, or was that just like the camera?
That's probably just the camera. Everything is falling. So here's a fun fact.
Like
so,
his body is picking up speed as he gets lower.
So he's accelerating until he reaches what's called terminal velocity, and that means he can't accelerate anymore.
Okay.
So that is, if you hit the ground at terminal velocity, you're dead. I don't know if someone survived hitting the ground at terminal velocity, but like, it's pretty much the size of the Earth has X amount of gravity because of its size and mass, and then you as a person have X amount of gravity because you have size and mass.
Right.
Everything exhibits gravity. Everything has gravity. So two objects attract each other because they warp space-time, and that's what gravity is. That's all it is. So
Joe, you should be a high school science teacher.
I don't want to talk to children.
Joe, I think
Seriously.
you think you don't want to, but I think you do.
No, I want to be I want to be like the cool guy at a head shop.
You could be the cool science teacher who smokes weed with the kids after class.
I don't want to do that.
All right.
I don't want to do that. So like a planet like Jupiter has a faster terminal velocity because it has more mass. Right? And here's another fun fact, jumping on that same thing. In orbit, you know how like a satellite orbits the Earth? The moon orbits the Earth?
I've heard.
You've heard?
I've heard.
That is technically just falling towards the Earth. That's all an orbit is.
That kind of stuff fucks me up.
I can explain it very easily right now.
All right.
So, okay.
You got 10 seconds.
So the man is falling towards the Earth, right?
Yeah.
Okay?
Yeah.
Now, he is getting slowed down by the wind resistance, by the air. It's like falling through an ocean, except it's less dense, and that's what the air is. The atmosphere is just an ocean for people.
Right.
That's basically what it is. So
ocean for people.
When you go above the atmosphere, the ocean is now gone. You have no resistance. Mm-hmm. Okay? So you fall with no friction. Okay? So an orbit is basically you take an object and you drop it, and it's falling towards the Earth. But since it's above the atmosphere, it now has no friction. So I assume you're asking, well, what? I don't understand. It goes around the Earth. It's not falling towards the Earth. You're making no sense, Joe.
You're making no sense, Joe.
That's because the object also has a force. It doesn't have a force. It has momentum going parallel to the Earth. Mm-hmm. So it's actually going sideways. But as Newton says, objects in motion stay in motion. So since there's no resistance, the object it continues to have that force sideways. It continues to have that velocity. Mm-hmm. But it's also falling towards the Earth. So it's going down.
This stuff fucks me up, Joe.
So I'm almost done with this. But it's going down. You would figure it would just go towards the Earth. But the curvature of the Earth is a round sphere.
Right.
So it's actually going down at the same exact rate that the Earth is curving below it.
I hate this, Joe.
So
I hate it.
The object is falling down, right? The Earth is curved. So it also has a velocity going parallel to the ground. So as it falls down, it can't catch up to the curve. So it never hits the ground. It just continues to go in a circle. And that is what an orbit is.
I hate it.